Cool. Welcome to the Veritas Automata podcast, deep dive with Ben and Saurabh, or whatever chaos we create. So for those of you who've never met me in real life, I have a psychic ability to break any piece of technology that I encounter. And so today we've gone through 2 mic setups and found at least 1 bad cable. And this is all the same stuff that we used last time. So be prepared for, as Saurabh said it, we're going to wing this a little bit.
Yeah, absolutely. And, knowing from the experience, it does happen whenever Ben walks in a room, technology breaks. All right.
Cool. So I think the first thing we're going to do, because we got a new toy to play with, we got our hands on our own set of A6000 GPUs, which means we have 96 gigabytes of video RAM to play with for loading models, whether they're video or training or other things. And so what's the best thing we can find to first do with that? We're going to make large language models fight it out.
Absolutely.
So as I get the screen shared, why don't you share a little bit, Saurabh, about what we're actually doing here and what models we're using.
So what you're going to see today is 2 large language models controlling 2 Street Fighter characters and duking it out. So it's on a simulated arena where each of the models are getting textual description of what's happening. I'm going to run it as this thing spins up.
Yep.
And from the image of the screen, it's able to find out where each of the characters are, and each of the characters are controlled by 2 different large language models. One is Gwen 2.53b, the other one is Llama 3.23b. And what they are doing is they are looking at other players, where they're located, how much health they have, what moves they're playing, and they plan their moves accordingly. So what you are seeing is these 2 characters are being controlled by 2 different large language models. They have very interesting moves, as you can see, but this is an unconventional way of using large language model, but it's fun. So, it's part of discovering what a large language model can do besides writing, interesting marketing material or research papers. It is also planning moves ahead of time. So, large language models are tend to be slow, but here you can see they are planning moves quite a bit ahead of time, and the emulator is kind of taking them and running them through.
Well, and I think what has us excited, and we'll be clear, we didn't write any of this. We're actually leveraging an open source repository that we found that we'll share both for this and for the actual core game engine that we found. But we thought it was a really interesting way to apply LLMs in a different context for us to learn more about the way that LLMs work, and to put our new server through the ringer to see what we can really do with it. So we're super excited about what it can do. So we'll share the links to both the core repository, which I think is Diambra, is the core.
Yeah.
And then there's an OpenLLM Coliseum, which is what we're actually running to do the Street Fighter.
Right.
And it's going to give us some excuse to do some different prompting as well. So it won't be just testing large language models against each other. It'll be testing some of our prompts eventually against each other too on the same model. But we thought that was very entertaining.
I mean, it kind of segues into some of the things we have been planning to talk about. Large language model, it's not just a generative AI. It has a strategy thinking piece of it. Again, it's learned from a lot of the data that it has seen, that you can see through some of these stuff. So it's not going to just text in, text out, but it has some nuances around it.
Yeah. So I think as we talk about large language models, in particular in generative AI, last podcast we talked about, a little bit about fine tuning and about retrieval augmented generation, or RAG, and we are going to do a separate session just on prompt engineering. One of the things I think we've all seen is a lot of people spend a lot of time on the prompt engineering piece of this, and they don't really understand what other pieces they need to focus on, because a good prompt doesn't do a lot if the data is bad or if there are other issues. Right. So let's first talk about, for now, we'll stay focused on the fine tuning versus RAG. Next podcast, we'll probably dive into some more demos and also some more on the prompt engineering. But let's stay on fine tuning and RAG, and then we'll go into data, because I think we've got some interesting stuff to talk about there.
Yes, absolutely. So let me give my 2 cents on fine tuning and RAG, how I see it from the data scientist point of view. So fine tuning is where you are retraining the model. Not completely from scratch. You take a pre-trained model, a vanilla model, and then pass it through your data and train it. So it learns about your data that it hasn't seen before. Maybe it was not public, it's a proprietary data, so you train the model from to learn about your data and the knowledge base. The RAG is slightly a different animal. You don't do retraining of the large language model, but when you are asking a question, you are also providing through the pipeline what are the relevant knowledge that needed to answer that question. So it retrieval augmented generation. So the retrieval part, it's a completely separate pipeline wherein the question is parsed by the large language model into an embedding or a vector, and then goes out and looks through your repository and find some of the closest knowledge tidbits that matches that question closely. It may not be an exact match, but closely, and then pulls them down and passes it to the large language model, asking, hey, how do you answer this question based on this context? So, and it then answers the question.
So what would be a good example of a use case where you choose fine-tuning over RAG?
So, there are typical advantage of RAG. As you can see, the retrieval piece of it, you don't need to do retraining. So your data set could be online, real-time changing. Like, for example, a chatbot on an e-commerce platform, about your inventory level in real time. When you're asking, hey, do I have this latest Nintendo Switch or whatnot? It does a lookup, says, okay, I only have one unit at this location, answers that. Versus if you think of fine-tuned model, it don't know that because it takes time to retrain the model, and that's a typical use case. But if your knowledge base is kind of static and it doesn't change that much, fine-tuning might be a better fit, because again, with retrieval, they're a lot more expensive in terms of computation time. You're going looking things up and then answering, whereas this is straight up prompting to the LLM and gives an answer.
So if I would start to, from a business perspective, because this is what I'm always looking for, is what are some basic business rules someone can use? If you are retrieving a lot of information, retrieval augmented generation is good. If you were doing more maybe content generation and your data is fairly static, then fine tuning can be good. Now with fine tuning, I think you do have some risk of overfitting the data. And I think the other thing you've got to think about for both, and you made a really good comment about this, is you've got to look at the total cost, right? And everyone is always focused on what is my cost to train or what is my cost to do an inference. So inference is when you're looking data up against the model. But sometimes you've got to look at what is the balance between those for my total cost of getting data out. Because if you are retraining the model every night, that may be very expensive, but it may be less expensive than doing continuous retrieval augmented generation and adding that content in. On the other hand, that actually may be less, because maybe now I can use a much smaller model for the retrieval augmented generation, because I don't need a 400 billion parameter model. I can do it with a 8 or a 3 billion parameter model.
Let me bring up another very, very cool point about RAG versus fine-tuning. With fine-tuning, you cannot trace where that information came from. It could have hallucinated or it could be a genuine source. But with RAG, since it's retrieving certain things, you can create citations saying that I know it came from this. So if somebody questions that, hey, why did you get that answer? It's easy to trace that down.
And that's a super important point, right? This is where, from our perspective, whether it's generative AI or retrieval or machine learning, it's really understanding what is the business case we're going to go apply it to, or what is the research thesis we're applying, so that we can figure out how does this actually work and how do we make sure that it's going to be the most accurate response possible.
Right. And with the fine tuning, it's almost about speed and the cost. It's very low cost and it's really fast, because you're just asking the large language model a certain
The inference is low cost, but to get to the point where you can do the inference can be more expensive in time.
Fine tuning is going to be very expensive. Again, you need specialized hardware to train it and all of that. But there are advantages. If you want some real time fast answers from the system, fine tuning is a way to go. But again, you need to figure out how do you control the hallucination. If you ask a question that it hasn't seen before, it will hallucinate quite a bit, because it's a probabilistic model. So it will find the nearest closest answer and pull it out. So
and I think the other thing you get too is this risk of overfitting the data. And you and I were going back and forth on Slack the other day about, I think it was one you sent me, but it was about watches, right?
Yes.
So why don't you talk a little bit about that?
Yeah, so there was an interesting tidbit that I came across, was that if you, in any of the large language, ChatGPT, for example, ask it to create an image of a watch with the time 3:12, you will get 10:10 most of the time. And the reason being, most of the images out there on the internet are at that 10:10, because it's very aesthetically pleasing. So the large language model learned the watches should look like that rather than 12
Yeah.
past 3. So it kind of is typical example of how the training data influences the outcome quite a bit.
So it's, and when you hear us use the term overfitting, what that means is that somehow you've gotten more samples of something that is not necessarily truly representative. Watches at 10 past 10 would be a good example of that. But when we think about it from a business context, this would be another decision point between fine tuning and RAG. If you don't have a very large data set, you may be better off to use retrieval augmented generation because you won't have enough data to sufficiently enhance the model, and you're going to get responses that are overly specific or not exactly what you're looking for because it just doesn't have a big enough data set to go find the answer.
Right, and fine tuning is also a little bit more complicated than RAG underneath because you could have more, like the model not getting trained. There's a failure in the pipeline. There's hundreds of different things. It could even have catastrophic forgetting. So it would forget a lot of the things because you're packing too much of the new stuff in there. So it is more of a nuanced, approach to a practical application of a large language model, I would say.
So. And there are some opportunities to combine both techniques.
Yes.
And I'll ask, I think this is possible, and I'll run it by you. But if I am dealing a lot in, let's say, the life science and healthcare space, there's a very common set of codes that are used for different kinds of diagnosis.
Yes.
I could take a model that is not familiar with those. I could fine tune that in.
Yes.
And then combine that with retrieval.
Yeah, absolutely. So, the chemical name of drugs, again, there are multiple different variations of it. And if you can fine tune that because that's not changing that much. But when you do RAG, when you are asking about drug A, it knows that it also means drug C and so it's the same drug. So when it's doing the RAG, it's not failing that knowing that, hey, okay, retrieved context or information with a different name, but it's the same thing and it's able to answer you back. So a hybrid approach would work really well in situations where you are teaching the common knowledge or the business knowledge.
Well, in particular for specialized industries, right, where they've got very specific terminology.
Acronyms and all,
and that, again, you're going to hear me hop on the bandwagon of I really like the idea of the small language models because you can run them in lots of places. So as we talk about this is where you can take that model, you can add a little bit of intelligence to it, and then make it really super powered for someone's retrieval augmented generation versus just an off-the-shelf, even OpenAI API call.
Yeah, absolutely. So the large language model is not something you can take off the shelf and fit it in a business and expect it to work. It's all,
you're going to get results. You're going to get responses back.
Right. But you have to tailor it to your business case to be really effective, or else you're chasing why is it hallucinating, why is not giving me the right answers. So there's expertise in putting all of that together besides the whole data science or the data scientist part of building those large language model. But even taking something open source and fitting in your business use case needs a lot of deliberate thinking and kind of asking right questions on what answers or what problems are we trying to really solve with this.
Yeah, well, and particularly when you start talking about that, and this is something I think we'll talk about in some future ones too, is the idea of red teaming and making sure that all of that is secure, because it's really easy to get something up and running. And now I've created this retrieval augmented generation beast that is going through all my corporate data, and all of a sudden someone is getting access to data they shouldn't because you didn't build those different protections in.
Yeah. So, having those role-based access control in the pipeline pretty deep inside is very, very key. Because if putting information where it belongs and not letting everybody, who doesn't have access to see it, is all outside the large language model itself. But it is kind of very, very important in the setting. So, just throwing entire repository of knowledge at it and expecting it to kind of know what a CEO can see versus somebody like an intern is able to see, that becomes very, very important, and also mitigates a lot of the risk around it. Yeah.
Well, and I think some of that too is understanding, when you look at models, all models are built from one company's perspective. So when I'm using Llama versus Quen, they come from different companies, they come from different regions, so they're going to have some different things built into the model itself. So understanding those becomes important because that's going to drive some of its answers to you. I'll use an example. I was in a meeting that had become non-productive. I'll fully admit that. And I was asking the large language models on how to organize a proper goat rodeo. can tell you what my opinion on that particular meeting was. But the challenge that came as I was going through these is different models, even different versions of Llama responded differently because they built different context into the model itself. Right. And some would say, well, you can't do this because it might hurt the goats. And some gave a very detailed thing of all the games you can play with the goats. And others would say, well, yes, and then be prepared to go herd the goats because once they get loose, it's going to be a challenge and you might need rope and a taser and other things. You're like, wait a minute, these different models. So understanding all those things are going to be important because it's really easy to get something to work or to ask a model a question. The important thing becomes, how do I make sure I'm giving a valid business response for the particular business problem I'm working in? Because you don't want to give something that is wrong based on that business context, right? You don't want to go tell someone it's okay to go play rock and roll in the lunchroom if you're in a business where that's not appropriate, as we think about it.
Yeah, I mean, we were experimenting with an RAG setup we were doing with clinical data as well. So, when it was answering question, we asked it, can you answer that in a like a rock song kind of version, things like that. It's fun, but again, it's probably not a business.
Maybe not the best thing to go for cancer study.
Exactly.
So let's talk about that, right? Yeah. So, one of the challenges when you're getting things ready before, to make sure you're going to be able to deliver the right solution for our customers, where do you get sample data sets? Yeah. And we found this sample data set of thousands of FDA clinical trials that were successfully completed.
Yes.
Right. And so we've brought a portion of those in.
Correct. Yeah. So we have, we have a couple of versions in the works, but the one we are interested, we can show today is it's around 6,000 sample studies out. It's just randomly sampled data. So, when you ask it a question, instead of, what, technicians go and do Google search that to find that, now you can ask the RAG or the agent, which could be a front-end based or a website-based thing where you have credentials log in and look at it, or it could be integrated into the Teams or the Slack, the business communication agent. So you can simply ask a question, it retrieves the answer, shows the answer, and also gives you the relevant studies with URLs on it so that you can go double check it. And if something's odd, you can double check that and go deep into it. So it's a very useful tool just to play around with. And we found that it's clinical studies are kind of hard to read because they are scientific documents, but it was able to navigate through that and come up with really relevant answers as well. So it was an interesting thing.
Cool. So we'll fire that up in a minute, but you mentioned that we've got a couple versions. So we've done one version in Slack, because that's what we use as one of our internal corporate tools. We've done another in Teams that is one of our corporate tools. And then we've done another that is just web-based.
Correct.
So today we'll go dive into the Slack one. And then next podcast, we'll dive deeper into how we architect for retrieval augmented generation type solutions in Azure in particular, and show that with Teams. All of these tools have different benefits and different challenges they provide, right? To do it in Slack, you've got to approach your data security model a little differently than you do in Azure and in Teams. So now we'll get ready for yet another live demo. And I will pull up the screen there. Cool. Okay, so I've got it live. Do you have a particular question you think I should ask?
Maybe let's ask about latest studies on breast cancer.
And you're all going to see what a poor typer I am.
Let's see if you can break the demo this time. It might.
So here's a question. I was actually talking with someone about retrieval augmented generation the other day. So this is doing a live query, by the way, to our demo system. They were asking, how do you handle the idea of prioritization? So, study A is newer than study B.
Right.
So how do you handle that prioritization for the system?
So, the dates are also available on a lot of these studies. So, you can start to do multi-level filtering already, saying that I want to see all the studies done in 2023 or 2022 or 2025 or whatnot. So it's able to handle a lot of that. We also engineered metadata-based filtering system around it. So, you could not just depending on the large language model, but you can also engineering some of those pre-filtering done already data to fasten a lot of these solutions out. I think you got an answer, as you can see over here. So, it gave you our answer. If you hit the read more, it's the bigger part of the what it kind of found out. And then the references, where it pulled all of the research materials that it pulled to answer that question. And if you hit one of the URL, it should pop up the research, directly take you to the clinical study data itself.
Yeah. So I'll have to reshare my screen to show that, because
Okay.
I was just showing a specific tab. So there we go. So there's the model. What I'll do actually is I'll simplify this.
Yeah.
See, I warned everyone, I break technology and do weird things to it. There we go.
Yeah.
I'll just share this particular window.
Yeah.
And so now this is the case study that just came up when we clicked the first link.
Yeah.
But if I click this link, it will bring up a different study.
Right. And you can see that, it's pulling the right resources or the right studies out there, and you can verify what it's saying about it. The cool stuff is you can continue to have conversation and ask, like, hey, can you compare each of these studies? So it knows that what studies are you referring to, because it has answered it prior, right? So so you can go down this research rabbit hole, for lack of a better term, and kind of get to the answer you're looking for. You start at a high level and then kind of keep digging and digging into it. So it's going to help you quite a bit on that side of the research as well.
I'm going off script. I just grabbed one of the drugs that it mentioned, and we'll see what it does.
Yeah, why not? Yeah, we don't have a script. we wing it every time.
But no, I think when you build these tools, though, you've got to think about that, right?
Yeah.
A user's going to go in and they're going to go follow in different ways
Yeah.
than the engineer would. And that's why it's
Right.
very important when you build these to sit with the business side of the team
Yeah.
to understand what are the things they're trying to create, why are they trying to create things,
Right.
what it provides value to them and what doesn't.
Right.
Because if you don't do that,
Mhm.
you're going to engineer a really good solution that doesn't always meet what the users need.
Yeah. So it looks like you got an answer there.
I'm looking for something that's got more, because this is just giving me two. I'm looking for something that's got maybe.
Remember, it's only based off 6,000 studies. So, some of the things it may not have it on its repository. I'm just caveating it.
Yeah.
But, underneath, we have been working on the larger data set with 66,000,
And the real thing for us is to give us a solid data set to be able to run these, to make sure that our pipelines are good. So I will turn that into an open question to our audience. If you know of interesting data sets we should look at through a tool, through a large language model, or through other machine learning type tools, we'd love to see those so that we can run some examples. Or if you've got some questions you'd like to see us run against this data set, we'd love to see those as well. So we can say, okay, what happens when we do this? 'Cause we're very much in that, we don't know what's going to happen. So let's try it.
Again, this is my rough estimation, but I have found RAG to be an accelerator in looking for the data quite a bit. So, instead of Googling it through whatever Google and, other search engines, if you ask a RAG, it gets to the answer much quicker because it's doing more of a language search rather than keyword search underneath the hood.
But yeah, I think this is where the fun comes in, as we start to do these experiments and see what happens and what's going to be next.
Yeah.
So as we think about these kind of tools, what's been the biggest surprises you've built some of these, particularly in the retrieval augmented generation space, that surprised you in a good way or a bad way, where something didn't work as expected?
So what I've found out that the RAG is especially good for finding correlations between multiple different knowledge tidbits and coming up with a more of a holistic answer. So think me as, in a researcher's shoe, if you're looking for a certain thing, I come across something and I would kind of hook onto it and go down the rabbit hole because that's the first thing I found. But with the RAG, since it's pulling all the relevant information and creating a summary, so it had broadened my laser pointed view to a little bit more wider scope. So I'm seeing the same answer from different lenses. So it helps me as a researcher quite a bit to kind of attack the problem. Okay, yeah, I have one path to an answer. What about that one? Maybe that's more optimal for what I'm trying to do. That, helped me quite a bit. If you think about the old way of searching, like at Google, you cite something, you find a relevant paper, and you go down the rabbit hole trying to download the sample code and run it, and then you're trying to fix it. But there could have been another solution, 4 or 5 results down, that you would potentially overlook, right? Unless you are a very, very meticulous person and you are trying to look through everything. But I'm not. So that RAG helped me quite a bit on that.
So most RAGs use a vector store. I guess all RAGs use a vector store of some form, right?
Yeah.
But you've also got a variant of RAG, the graph RAG, right?
Yes.
And some of what you're describing almost sounded more like using a graph. So for those of you who don't know, a graph is more, think about Facebook, right? It's establishing specific relationships within data, which are, I'll call them more solid than the statistical probabilities that would come from a traditional.
Right.
So how do you think about when to apply those two tools?
So I think when you are doing research, like I described, graph, it's probably also a pretty good tool to have, so that, when you are doing retrieval, it's actually trying to match the English language of your question with the context behind it. But the RAG goes one concept deeper. It's connecting relevant knowledge
the
graph RAG. It is connecting different knowledge bits which are connected to each other or dependent on each other. So it's when it does the retrieval, it does a better job of pulling that out and coming up with a better answer, rather than think of retrieval today is more of a, hey, you ask a question, this is the closest that sounds similar. But graph is, hey, I found that, but let me go down the chain or the hierarchy and find other things that might be relevant and pull that out. So it's better retrieval, but again, it's more expensive in terms of running it. But again, it all depends on the business use case you are looking for. If you're looking for inventory, what's my Nintendo Switch looks like, straight per inner lag. But if you're doing a clinical study on a certain drug, maybe you want to do the graph-based setup.
Well, and some of this too, everyone will hear us talk about the idea of LLMs really as interfaces to these tools, as chatbots, as interfaces. So you're powering it via the large language model. So even like the inventory, you may actually not even do that as a RAG, right? You may just do that as a separate, as a separate tool.
Yeah. So for purposes of the LLM, it doesn't distinguish how the context came in. Is it text, or you ran a tool and ran a SQL query to get the latest inventory and then pushed it in, and then it sees, okay, I have 10 Nintendo Switches, so it knows they then runs.
But that's another way to, call it a variation of RAG, the tool use, to be able to give you a way to know absolutely what is the right answer and not have to worry about, what I refer to as the teenager. Did the teenager do their homework, or did they clean their bedroom problem that a lot of large language models have, which is they say they gave you the perfect answer, and then you go look at it, it's like, well, you made it all up.
Yeah, absolutely. So, think about this. Since I said that retrieval could be also tool use, you could run analysis on it, saying that, hey, if say a financial advisor is asking about certain stock, it can trigger that tool to pull like 1 year worth of data. Does their operation push that back as a summary, saying that I see this is indicator that, and let the LLM do the rest of it. So it is very, very malleable, because the common platform is English language or textual or tabular data. If you can get that to that, LLM is able to take that. So that's what the generalization.
So kind of on that about tool use in financial models, you and I were talking about that article that I'd found about using large language models to evaluate bank models, bank financial models or risk models, right?
Yes.
And so they were trying to use the large language model to do it. But in some ways, it sounds like using a more conventional machine learning tool would have been a better solution.
Yeah, I would use the same paper. The way I would approach is use language model on the top as a conductor, and have multiple specialized tools do the analysis. Is my data clean? How did you explain the abnormality, and et cetera, before you kind of validate the model for financial.
So how would you differentiate like a structure like that versus what a lot of people are talking about as agents, right? Because there's been a lot of noise about agents over the last couple of months, both with open source models, with like Crew and AutoGen, and then with some of the announcements from Claude and from OpenAI about being able to use your computer.
Yeah, so think of this way. The one I described was you had one brain, and then it was using multiple tools. Agents are like you have one brain, but then you have little sub brains. They are looking for certain things. They can use their own tools and come up with their inferences, but they're specialized to just look for those signals. And there you can then use the multiple. So it's like a hive mind versus a centralized queen bee kind of setup. If you lack for better, I gave you a movie reference, but that's the difference between our agentic approach is a little bit more complex, but it has more generalization capabilities than just straight up using tools.
But more challenges about dealing with the risk of hallucination and other things because of that complexity. It's not that it's inherently bad. It's just you've got to take that complexity into account.
Yeah, it's having a lot of interns versus Yeah, I'll leave it to that. But that's the idea. They could hallucinate, not do the work. And I think in the last podcast we talked about, we were trying to use agentic where it supposedly done the research. It didn't. It came up with its own answer and then passed it on. So you have to control for a lot of that as we go along, in that path.
Cool. Well, we're coming up on 30 minutes. So what are the coolest things you've seen over the last couple of weeks in machine learning? So this is always in Gen AI, right? This is always moving.
Yeah, so what I'm seeing more and more trends is that if you see the open source models are catching up to the closed source very, very close. The Gwen models are really, really good in solving logical problems. And the other big evolution that's why we kind of did the LLM Street Fighter is that earlier it was always viewed as something that can generate more text, but not in strategy planning and all of that stuff. And you can see that problem solving. People always say that, hey, large language models cannot solve puzzles and things like that, but you're seeing more and more that happen. I think it's very interesting. The other side, I would say, is in terms of the tooling. It's getting easier and easier as we go through it, and we are trying to embed that into practical solutions. The toolings are getting better and better. The other day, I saw another tool that it can take control of your browser and navigate through an unknown website, and do so. It's using vision based, like
was that the Claude agent, or was this an open source tool?
I don't remember very clearly what it was about, what was underneath, but what it was doing essentially, it was taking screenshots and identifying where the buttons are, what are the different elements underneath, and then kind of coming up with a strategy to do certain thing around it. So you are not coding an RPA, hard coding based on the all the browser code, but kind of making it more dynamic around it. So
and I think that's something interesting. I think that we're gonna have to put that on our list of things to go play with, because I've talked with some folks about it. And one of my concerns with that is, like with RPA, you can make that very testable, so you get a known result every time.
Yes,
and that's what I would want to figure out, is how to do with those large language model based agent approaches for it. Is how do I make sure that I can verify it's doing the right thing and not getting stuck or repeating old data or something like that.
Correct. Yeah. I mean, validating the answers of large language model is probably the golden challenge. If we solve that, it creates that repeatability even in a probabilistic environment. So that could be very, very interesting.
So I think we just found another experiment we got to do.
Yeah. Oh, I know.
I think things I've been interested in. I don't think I shared these articles with you. I was actually sharing with another friend who I think well on the podcast. But we were talking about using large language models for software development. And there was a series of articles that came out from a couple of different authors, and we'll post those as some of the links as well for this. And one article was pointing out that in a lot of cases, when you're working with these different models, particularly I think they were using Claude, you can get it to ask it to write a program, and then you can get it to enhance the program just by saying write better code.
I've seen that too.
Which I thought was pretty interesting. And then the counterpoint article was you can actually do even better than that by doing more of a chain of thought type approach, by having a fairly detailed set of requirements that you're asking it to write the code to. So don't just ask it to write the code to play a game. It's write the code that has these kind of features and this kind of functionality.
In my personal experience, in cases like that, I would start like test-driven kind of development, come up with what the input and output is going to look like, and then kind of have the LLM do it. So it's strategically thinking where the boundary conditions are and outliers are.
So it's almost like back to the origin of Agile program, right? It's write the prompt that says, as a user, I want to do X so that I can achieve Y.
Yes. So I think this is an interesting development. So it's going to accelerate development of code quite a bit. So
I think I want to wrap it after this so that we don't keep going too long, because we could talk. We do talk about this all day long. But I think one of the challenges you have is you still have to have a good way to teach developers how to actually code, and how to understand how systems work and how to diagnose them. Because if you're just putting everything into a model, you don't have a way. You don't understand how to troubleshoot it. And if you don't have those fundamental understandings, you can't actively troubleshoot it, and the code will go wrong. I mean, you and I were working on setting up the GPU server, and just the number of little things that happened that, because we've been around the block a few times, it's like, okay, we know what the fix is, and it takes us 5 minutes to go do it. Whereas if no one's ever done it, because it's all in large language models and they're just pulling queries, they might not actually be able to fix stuff.
Exactly. Wrong rabbit holes to start with.
So Cool. So next week we will go through the web interface to the FDA data, and we'll go into the Teams agent that we've built. And we'll talk a little bit about the architecture that we've done with Teams there, and how we're helping to apply that for folks.
Yeah, it's very, very cool with Teams, especially with the permissioning and all the stuff built in.
Yep.
It's seamless, kind of. It's pretty cool.
So you'll see me post a LinkedIn link to some of the different URLs that we talked about for where we got the Street Fighter model and other things, and some of the other ones that we spoke about. So we're excited to talk with anyone who's interested about talking about these subjects, because we find it really fascinating. We're doing a lot of work on our own, and as I said earlier too, if anyone has any interesting data sets they think would be fun for us to do some examination and experimentation with, please share those. Or if you have any questions you want us to ask our tamed tools that we have at the moment, we'll see what happens, and I can give some of our team another heartbreak, or heart attack, I guess I should say, because the model, there was no heartbreak. Their tools worked well in the live demo, and we'll stress them a little more.
All right.
So cool. Thanks, everyone.
Thanks, everybody.